Okay, welcome back to math class, and welcome to 10-5. What we're going to be talking about today is a little bit different than what we've been doing the rest of the chapter, because today we're going to be talking about points on a coordinate plane. So imagine, if you will, you have a coordinate plane, and you have the points 5, -6, so 1, 2, 3, 4, 5, and -6, 1, 2, 3, 4, 5, 6. I'm going to call that point F at 5, -6. And you had another point at 1, 2. I'm going to call that point G, 1, 2. Suppose you had these 2 points, and I was asking you to figure out how far is it from this point to this point. What we're going to do, one way to think of that is imagine if we had an imaginary right triangle all the way down to here and like this. And we're going to use the Pythagorean theorem from yesterday to figure out our third side, our C, based on, or I'll call it D for distance. Our distance between these 2 points, we use the Pythagorean theorem. If we know the 2 legs, then we can find the hypotenuse. So now our only problem is how do we find, because we know that a squared plus b squared equals c squared, right? The legs squared added together equals the hypotenuse squared. So the only thing is now I have to figure out from here to here and from here to here. So I have to figure out the change in y and the change in x. So side A is going to be the change in y, and side B is going to be the change in x, or vice versa, either way. Then I would take the square root of all of that, and that would give me the distance. What that's going to look like, all written out, we call the distance formula, and it looks like this. Distance equals the square root of x2 minus x1, so that's my change in x, my x2 minus my x1 squared, plus my y2 minus y1 squared. Now that looks really complicated, but it's just rewriting our Pythagorean theorem in a different way. And all you have to do is plug in your points and then solve one step at a time. So that's what we're going to do for this problem, okay? Now you remember the first step when we have y1s and y2s and x1s and x2s is I'm going to write out my points, 1, 2, and 5, -6, and I'm going to label them x1, y1, x2, y2, right? Now I'm going to plug those values into my distance formula. So my distance is going to equal the square root of x2, which is 5, minus x1 squared plus my y2, which is -6, minus my y1, which is 2, squared. Okay, now I'm going to simplify it one step at a time using my order of operations. Hopefully you also have committed that to memory. You remember PEMDAS, That's how we remember it. Now the first thing we do in PEMDAS is parentheses. That's the P, parentheses. So what's inside our parentheses here is 5 minus 1. So we're going to do D equals the square root of 5 minus 1, which is 4. We leave that squared. Plus negative 6 minus 2, which is negative 8 squared. Okay, next in our order of operations after parentheses is exponents. So now we're going to deal with our exponents. So we're going to do D equals the square root of 4 squared, which is 16. 4 times 4 is 16, plus negative 8 squared. Negative 8 times negative 8 is 64. All right, we don't have any multiplication or division to do, so we move on to addition and subtraction, and I'm going to do D equals the square root of 16 plus 64, which is going to give me 80. Now 80 is not a perfect square, unfortunately, so we're going to have to put the square root of 80 into our calculator and get D equals, well, we can't do it exact, right? So we're going to do D is about 8.9. Now at this point you might be thinking to yourself, I know when I take a square root that my answer is going to be plus or minus, so 8.9, positive 8.9, or negative 8.9, right? But we can't have a negative distance. We can't go less than 0 if I'm going a distance. So whenever we're doing distance problems, and only distance problems, we know that the answer has to be positive. So it's not going to be negative 8.9 in this instance because we're doing distance, and we can't have negative distance. We can't go forward less than we started. Okay. It's long and complicated. This was just one problem, finding the distance between 2 points. But as long as you keep your parentheses separated, make sure you're plugging your values in correctly, make sure you're labeling things, and make sure you follow your order of operations, you can do this. Now it might happen that they give you a third point here, like this, -3, -5. We'll call it point E. And told you that this was a triangle, and asked you to find the perimeter of the triangle. Now, if I wanted to find the perimeter of a triangle, I would need to know the length of each side, and then I would add those 3 together, right? That's the perimeter. So what you would have to do in this instance, because this is not a right triangle, is you're going to have to do the distance formula between, so this D equals 8.9 is the distance, D is approximately 8.9, is the distance from G to F. So you would now need to do the distance formula from F to E and from E to G. And once you figured out what those distances were, you could add all 3 of them together to find your perimeter. It does add a layer of complication, but it's something you will know how to do. You'll just have to practice.